This page starts part 2 of chapter 6.1 in college algebra, where we're going to work with parabola that had the vertex at the origin. We're going to graph them by finding the focus and directrix and making an XY chart. Let's look at the equation of this parabola that we need to graph and examine it before we begin finding the parts we need for graphing. It's y equals negative 1/12 x squared. It is in the form of 4py equals x squared, or very close to it, which tells us this is a parabola that opens either up or down, with the axis of symmetry being the y-axis. This negative right here out in front tells us that the graph is going to open downwards. Our first step in finding the focus and directrix is to isolate the x squared. Then we'll solve for p so that we can find our focus. So my first step with this equation, so I'm going to multiply both sides by negative 12, and I get negative 12y equals x squared. From there, I take the negative 12, set it equal to 4p, and then solve for p, and I get negative 3 equals p. P, if you recall, is our focus. In this case, it's my y-coordinate of the focus. So my focus now is 0, negative 3. That's a point I can graph. My directrix I find directly from the focus, and it'll be y equals the opposite of p, or y equals 3. Let's go ahead and plot the focus and draw our directrix. So this is 0, negative 3 is my focus. My directrix is y equals 3. So I'm going to draw a line here where y is equal to 3. Shift it down just a tad. Next, I need to make an XY chart. Instead of using my original equation, y equals 1/12 x, actually I'm going to use my y equals negative 1/12 x squared. I can put that in my graphing calculator, look at my table, and come up with an XY chart. Remember, you need to graph the vertex and 2 points on each side. So the points I chose to use were the following. Here's my values for x. I chose those because if you look at your XY chart on your calculator, you'll see that they came up with some numbers that are fairly easy to graph. When x is negative 6, y is negative 3, and so on. Let's go ahead and graph these points and join them with a smooth continuous curve. I have 0, 0. I have negative 3, 3/4. I have negative 6, negative 3. And then the ones that are symmetrical to it. And I will graph there we go. With a smooth continuous curve, we have a parabola that opens downwards. That, once again, that negative in front tells you it's going to open downwards. Here's another one. This one we're not graph. We are going to graph it, but we're given the vertex and the focus. And then we have to graph the parabola. The first thing we want to do is we want to graph the vertex and the focus and also graph the directrix to determine the direction, the opening of the parabola. So let's graph. My focus is at 5, 0. 1, 2, 3, 4, 5, 0. So my directrix is going to be on the opposite side of the y-axis. At y equals negative 5. Or x equals negative 5. 1, 2, 3, 4, 5. And there's my directrix. That tells me that this is going to be the equation where you have a y squared. equals 4px. When it opens on the side, what I mean by opening on the side, there's going to be a parabola that's graphed. It looks like this. It opens sideways. And I simply write the equation with 5 as p, and I simplify. So I have y squared equals 4 times 5x. That comes from my y squared equals 4px equation. I simplify and have y squared equals 20x. I make an xy chart and I graph the parabola. I graphed a variety of points here. I know the 0, 0 is on the graph. I saw that 5, negative 10, and 5, 10 were on the graph, and I didn't have anything in between, so I played with my calculator, changing my table set until I got some numbers to work with, and I changed my table set to increments of 0.2. And I took some whole numbers. So let's graph a few of these points and connect our points. Let's make this one purple again. Make it nice and fat so I can see the points. I have 0, 0. I'll graph the 1.8. 6 was 1.8 comes out to here. 1, 2, 3, 4, 5, 6. Right about here. I'm going to graph my 5, negative 10. Or 5, 10. And 5, negative 10. And 1.8. 1, 2, 3, 4, 5, 6. And connect these with a smooth continuous curve. If you notice, the further away your focus is from your vertex, the wider your parabola is. So that is how you graph a parabola, writing the equation, when you know the focus and the vertex. So here are some you can try on your own. You have to graph these, find the vertex, focus, and directrix of these, and find an equation of parabola satisfying these conditions. There are 5 problems for you to try on your own. When you're finished with those, let's move on to the word problems. Here are our word problems. Here's our first one. We have a car headlight mirror with a parabolic cross-section with diameter 6 inches and a depth of 1 inch. It tells us to position a coordinate system. That means the coordinate system, which means an XY graph like this, coordinate plane. We take the origin of this parabolic cross-section. We put it at our vertex with the x-axis on the x-axis being on our axis of symmetry. So I plotted my vertex. I drew my parabola that has a diameter of 6 inches right here. That's our 6 inches. So I went from 3 to negative 3 with my parabola. So it had a depth of 1 inch. So I just took my parabola, moved it out to 1 and 1. So I have this point on the parabola that is at 1, 3. And this point here it is 1, negative 3. It wants to know how far from the vertex should the bulb be positioned if it is to be placed at the focus. That tells us we need to find the focus, or find P. Well, I need to write the equation of this parabola. This was a parabola that opens sideways. So it's in the form of y squared equals 4px. That is the type of equation that I will use here. I know a couple points on this parabola. I know the point 0, 0. I know the point negative 1, 3 right here at this red dot I'm pointing at right here. I also know it has this point 1, 3. From there, what I'm going to do is substitute 1, 3 for x and y in my equation here, and I'm going to solve for p. That will give me my vertex. Excuse me, not my vertex. That will give me my focus. So here I have 9/4 equals P. I do 3 squared equals 4 times P times 1. 9 equals 4P, or 9/4 equals P. Therefore, the coordinates of the focus are 9/4, 0, which is somewhere around here when I'm putting my little pointer. Now, we substitute 9/4 into the equation y squared equals 4px from above to get the equation of our parabola, which is y squared equals 9x. So my actual solution to this whole problem is A. So to write the equation, it's y squared equals 9x, and the bulb should be positioned 9/4 inches from the vertex. Replay this section if you have questions on what I did. I was going to have you try this one on your own. See what you can do to get started. I'm starting you off to let you know that you need to make a drawing of all of these before you do anything at all with them. We have a field microphone, or also known as a parabolic listening device, used at a football game. It has a parabolic cross-section and is 18 inches deep. The focus is 4 inches from the vertex. So what they mean by 18 inches deep, if we were to put this on the coordinate system, if I put my vertex at 0, 0 here, it says it's 18 inches deep. So here it is a cross-section of this parabolic dish. So if you slice it, so it means a cross-section, 18 inches deep. You know my focus here is 4 inches from the vertex. There's my focus. It wants to know the diameter, or the width, of the microphone at the opening. So we're looking for this diameter right here, from one end to the other. Since it's 18 inches deep, I know that my x-coordinate here, or my point that right here, this red dot, is 18 and some value for y. What I don't know is this distance from the x-axis to this point. I also don't know the distance from the x-axis to this point where it's negative y. So they're asking me to find this total distance here. So I looked at the way I put this parabola on my coordinate plane. It opens to the right, so I use the equation y squared equals 4px. From there, I'm going to go ahead and substitute what I know. I know p and I know x. That's all I know right now. P is 4, so I'll go y squared equals 4 times 4x. Or y squared equals 16x is the equation of this parabola. I can put 18 in for x, solve for x, or excuse me, solve for y, because I put 18 in for y. I get y squared equals 288, or y equals the square root of 288. So that tells me that my distance from my x-axis to this point is the square root of 288. We're going to estimate that to be 17. When you put that in your calculator, it's about 17. So the microphone is approximately 34 inches wide when you multiply it by 2. Replay this section if you have questions on anything I did on this problem. And finally, I want to make sure you turn in the Completing Square Review worksheet that you picked up after the test. If you were absent, get one from the shelves by the door. Get help from someone who is here. If you need it, I will be looking at these worksheets. Go ahead and start your homework. Replay anything you need if you have questions.